This is section 13, Pearson R, in making sense of statistics. The Pearson R was developed by a statistician named Carl Pearson, and it is a widely used statistics for describing the relationship between two variables. The full name of a Pearson R is the Pearson Product Moment Correlation Coefficient. You can see now why we call it a Pearson R. It is, the symbol is an R, which is lowercase italicized. There are variations on the name of the Pearson R or Pearson Product Moment Correlation Coefficient, and you might also hear it as the Pearson Correlation Coefficient or the Product Moment Correlation Coefficient. Properties of a Pearson R. These are just the basic properties. So number one, a Pearson R can only range from a -1 to a +1. So number two, a -1 indicates a perfect inverse negative relationship. A perfect inverse or negative relationship, which is the strongest possible inverse or negative relationship there can be. And thirdly, a positive 1.00 indicates a perfect direct or positive relationship, which is the strongest possible direct or positive relationship you can have. The fourth basic property is that a 0.00 indicates the complete absence of a relationship. Please notice that I did not say 0, that it is a 0.00 indicates a complete absence of the relationship. If you write the answer, you should write the answer of a complete absence as a 0.00. Also note the closer a value is to 0.00, the weaker the relationship is, and the closer a value is either to the -1 or the positive 1.00, the stronger the relationship is. And this is a graphic representation. As you see, as you move toward the 0.00, you have the weaker or the weaker relationship as you can see from the arrows, and also as you move away from 0.00, you can see that you move from weak to strong to perfect. So here again, let me reiterate these points. Strong, moderate, weak are used with both positive and negative values of the Pearson R. No numerical values are given. Interpretation of an R may vary from investigation to investigation. Now, on a test-retest reliability, one way to examine test reliability is to administer the same test twice to a group of participants without trying to change the participants between administrations of the test. This will result in 2 scores. Let's also note that the interpretation of the values of R is further complicated by the fact that R is not a proportion. So, for instance, it follows that multiplying 0.50 times 100 does not yield a percentage. So in other words, a 0.50 is not the equivalent to 50%. So multiplying R by a 100 does not yield a percentage. And also, we also need to say that 0.50 is not halfway between 0.00 and 1. This is a problem in interpretation, and this will be explored further in section 14. In that section, you'll learn about a statistic that is based on R, and that may be interpreted as a proportion, which is then converted to a percentage. Also, if you're interested about additional notes on the interpretation of the value of R, you can look at Appendix B in your textbook. However, I will not be going over that at this time. This concludes Section 13 in your Making Sense of Statistics book.